Hi, I'm gonna do a few problems that we covered in the review session today. So one of the ones we covered was chapter 2, number 17. And before I do chapter 2, number 17, let me do a preliminary example. And here's what we have. Let's suppose you have 8 people and you want the 8 people to do 4 jobs, two people each, and whatever be the jobs, sweeping and laundry and cooking and let's say dusting. Okay, so you want 2 people to do 2 people to sweep, 2 people to do laundry, 2 people to cook, and 2 people to dust. Well, how many ways can you assign these 4 jobs to these 8 people, giving each job 2 people? Well, what is this? This is exactly the multinomial coefficients. So, these are distinct jobs. You don't have to worry about their ordering. Just, you have 4 distinct jobs. So just randomly call anything job 1, and you want to pick 2 people for job 1. So there's 8 choose 2 number of ways you can pick a person for job 1. And then 6 choose 2 number of ways you can pick a person for job 2. 4 choose 2 number of ways you can pick the people for job 3, and 2 choose 2 number of ways, actually just one way, where you can assign the leftover 2 people to what you call the 4th job. This is the same as the multinomial coefficient that one writes like this. So this is the number of ways to assign 8 people 4 jobs, giving each job to, assigning each job to 2 people. Okay, so that was just a preliminary example. This will help us do 2.17. All right, so now let's move on to that. Chapter 2, number 17. What does it say? Actually, sorry, I got that wrong. What this will help us do is do chapter 2, number 48. Okay, so first let's do chapter 2, number 48 before we do chapter 2, number 17. Okay, what is this problem? Chapter 2, number 48. What does that say? There are 20 people. What is the probability that among the 12 months in the year, there are 4 months containing exactly 2 birthdays and 4 months containing exactly 3 birthdays? So you have 20 people and you want 4 months of the year to have birthdays of 2 each. And then you want 4 months to have birthdays of 3 people. Okay? So that's 4 times 2, 8, and 4 times 3, 12. 4, 8 plus 12 is 20. So that is how you have distributed the 20 people. Okay. Well, total number of ways is easy. What's the total number of ways you can assign the people birthday months? Okay, well, firstly, we're assuming that all months are equally likely. So the total number of ways will be 12 raised to 20. That's 12 times 12 times 12. For the first person, there's 12 choices. Second person, 12 choices, and so on. So that's 12 raised to 20. Okay, now let's pick the number of ways we can assign 2 people each to 4 months and 3 people to 4 months. Okay, so first let's pick the 4 months, the number of ways we can pick the 4 months to have birthdays of 2 people each. So number of ways to pick the 2 people 4 months. Okay, how do we do that? Well, that is we can just pick 4 out of 12. That's 12 choose 4. And the number of ways to pick the 3 people 4 months is, after you've picked that, there's 8 left over. 8, choose 4. Okay? So now what do we have? We have 4 months that we have chosen from the 12, which will be birthdays of 2 people. Okay, and 4 months, whatever it be. Let's suppose you pick this one, this one, this one, and this one, and then you've picked 4 months to be birthdays of 3 people. Okay, so it doesn't matter what these are, but you could, for example, assign, these are particular months of the year. You could order them from January to December, so whatever here you could have, for example, for the 2 people months, you have March, May, June, and October. And whatever be the arrangement like that. Okay, so once you have your 2 people months picked out, how many ways can you assign the 8 people to these months? Okay, so what do? Well, we need to pick 8 people from the 20. How do we pick 8 people from the 20? We can pick 8 people from the 20 with 20, choose 8 number of ways. From the 20 to be in the 2 people months. Okay, now we have 8 people standing there and 4 months. How many ways can we assign these 8 people into these 4 months to each? Now this is exactly the preliminary problem I just did. So the number of ways we could take these 8 people and distribute them into the 4 months that are the 2 people months. Well, they're already, from January to December, there's already an order. So let's just take the first 2-person month and we will assign 2 people that way. Then the next one will be 6, choose 2, 4, choose 2, and 2, choose 2. Okay, so we've done that. Now out of the 20 people, 2 people have been chosen to be in 1 month. Another 2 have been chosen to be in another 2 have been chosen to be in a third, and another 2 have been chosen to be in one of the 12 months. Okay, now what do we have? We have 12 people standing around left over. What do we need to do? We need to assign those 12 people, divide them into 3 each, and assign them these, you can call them these 4 jobs or these 4 months. How do we do that? It's exactly the same like the previous problem I talked about with the jobs. The number of ways we could assign 3 people each to each of the 4 months will be 12, choose 3, 9, choose 3, 6, choose 3, and 3, choose 3. And you have to take a product, thinking of it as a multi-stage experiment. If you want, you could also call this 8, 2, 2, 2, 2, and you could also call this 12, 3, 3, 3, 3. Okay, so what's the total number of ways we can assign the birthdays following the requirement they have? 4 months have birthdays of 2 people, 4 months have birthdays of 3 people. What would that be? Well, we see that'll be 20, choose 8, times 12, choose 4, times 12, choose 4. So, sorry, forget that. Let me start again. Okay, so we've picked the months. 12, choose 4. That's the number of ways to pick the months with the 2 birthdays. We've done that before. Times 8, choose 4. The number of ways to pick the 3 people months. Then we multiplying it by 20, choose 8. Here we're picking the 8 people that'll be in the 2-month birthdays. Times 8, choose 2, 2, 2, 2. Times 12, choose 3, 3, 3, 3. Okay, that's the numerator. and the denominator will be 12 raised to 20. So this is the answer to this problem. So once again, reminding you, this is the number of ways I can pick the 4 months for the 2 people birthday. And this is the number of ways I can pick the 4 months for the 3 people birthday. And this is the number of ways I can pick the 8 people that will be in the 2 people birthday months. This is the number of ways I could assign those 8 people, each one of the one of the 4 months, and you're giving 2 to one of them, 2 to the next month, and so on. There's 12 people left over. I don't have to do a 12, choose 12, because that's just one. And the number of ways I can assign the 12 people that are standing left over, 3 each, one of those 4 months will be 12, 3, 3, 3, 3. We don't have to do any kind of 4 factorial or anything extra for those months, because already these months, they have names. So if you want, or they have numbers, if you want, you can think of this as the first month in the year. This is the month that follows in the year. Just arrange them chronologically and assign the people to them. Okay, just like we did with the sweeping and dusting and mopping and I forgot what the other job was. But anyway, so that was 2.48. I hope that made sense. And of course, in a situation like this, I do not expect you to carry this calculation out, but I would like you to, for some of it, at least elaborate. For example, over here, you could say that's 8 factorial over 2 factorial. Then you would have a 6 factorial, 6 factorial, and a 4 factorial, 2 factorial, 2 factorial, 2 factorial. Write this. Other stuff cancels out. If you don't remember, you could do it like this. Okay, and things would cancel out. Okay, so do show this little multinomial coefficient if you're going to use that. At least just show me that you know what it represents with factorials. Okay, so that was 2.48. And next, let's look at question number 17 from chapter 2. We concentrated mostly on counting today because that's really what people said they had trouble with. Chapter 3 and 4 are more, defined, well-defined, and not new type of thinking. There's more more defined directions you can take with problems. So anyways, we concentrated more on problems from mostly chapter 2, because that includes a lot of the counting from chapter 1 as well. Okay. So now let's look at chapter 2, number 17. What does that say? There's 25 people, and of these 25 people, there are 15 women and 10 men. Okay? They're lined up in a random order. So these 25 people are lined up in a random order. You want to find the probability that the 9th woman... So they're lined up in a random order, and you want to find the probability that the 9th woman is in the 17th spot. Okay, so what do you have? You have all these 25 people, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. Okay, so here's 25 spots. Okay, so what do you want? You want randomly you just put these 25 people, arrange them in these 25 spots. And what you want is the woman to be in the 17th spot. There should be a woman over there. And this in hierarchy or going ranking from top to bottom, this is the 9th woman that you see. Going from spot 1 to spot 17. Okay, so you want that one to be the 9th woman. Okay, so what does that mean? It means that these 16 spots will have 8 women, of course. And there's 16 spots, so it'll be 16 minus 8. It will have 8 men. Okay, so these 16 spots need to have 8 women, and the 16 spots need to have 8 men, and the 17th spot needs to be a woman. So what's the probability of this? Okay, well, let's take a look. Okay, how do we calculate this? Okay, so let's look at the numerator. What will the numerator be? We want to pick 8 people from 8 women from the 15 women to be in the first 16 spots. So here I've just picked 8 women, okay? And I want to also pick 8 men. Okay, and so here now I have a collection of 8 women and 8 men standing around. I need to arrange them in the 16 spots. How many ways can you do that? That will be 16 factorial. So 16 factorial is the number of ways I can arrange these 8 women and 8 men in the 16th spot. Order matters. Okay, then what do I need? Then in the 17th spot, I need a woman. How many ways can I pick a woman to be in the 17th spot? Well, there's 7 women left over. So I could pick any one of these. And how many ways can you do that? That's just 7. Okay. And what do? You want to divide this total by the total number of ways you could arrange people. Well, what's the total number of ways you can arrange people? Okay. We don't need to care about what happens from spot 18 onwards. We just need to care about what's going on till spot 17. Okay. So how many ways can you take 17 people from 25 and arrange them in order? Well, that would just be 25 P 17, correct? This is a permutation, order matters. Okay, so you could write down what this turns out to be. What will it be? 16 factorial, 15 factorial, 8 factorial, 7 factorial, 10 factorial, 8 factorial, 2 factorial times 7. That's the numerator. And what's the denominator? It'll be 25 factorial. And what do you have? You will have 8 factorial down here. Okay? So that's the final answer. Of course, you can do some simplification over here. A lot of stuff will cancel out. Okay? All right.